Welcome to today's tutorial. Today we want to see how we can differentiate some functions. Here we have three different functions to differentiate. The first one, the function y equals x squared minus 1 all over x squared plus 1. Then the next function y equals cos to the power 4 of x. And then the third function, x squared plus y squared equals 16x. We want to see how we can find the first derivative, finding dy dx. Okay, so let's start. The first function, y equals, the first function, y equals x squared minus 1 all over x squared plus 1. X squared minus 1 all over x squared plus 1. Now, if we look at this function, it is a rational function. There is a numerator and there is a denominator. So the method says we should use the quotient rule. The quotient rule says that if we have a function that has a numerator and a denominator with functions u and v, then the first derivative with respect to x, we are saying that this is a function of x, this is also a function of x. It will be, we square the denominator, we carry it up, multiply to the derivative of the numerator minus the numerator multiplied to the derivative of the denominator. This is the method known as the quotient rule. So here our v of x is x squared minus 1 and our u of x is x squared plus 1. So we apply this expression there. We're going to get, we square the denominator. The denominator is x squared plus 1. So we square it. We take it up, x squared plus 1 multiplied to the derivative of the numerator. The derivative of the numerator of x squared minus 1 is simply 2x. Okay, we differentiate this and we differentiate that. Remember, when we differentiate the constant, we have a 0. Differentiating x squared is 2x. Then minus, now what we had up there was x squared minus 1 into the derivative of what we have at the denominator. So we differentiate this, we differentiate that. When we differentiate x squared, we have 2x. And when we differentiate 1, it is 0. Okay? So now we simplify our expression. We multiply this out with 2x. So we have 2x multiplied to x squared is going to give us 2x cubed. 2x multiplied to 1 is 2x. Coming over here, we'll open this one also with respect to 2x. 2x multiplied to x squared. Remember, there's this subtraction. So we're going to have 2x cubed. 2x minus multiplied to minus become positive. So 2x times 1 become positive 2x. All of that divided by x squared plus 1, all of this squared. So this gives us, we have 2x cubed minus 2x cubed. They cancel out, 0. So we have 2x plus 2x. That gives us 4x all over x squared plus 1 all squared. So our first derivative with respect to x for your first exercise A. The expression for the first derivative is 4x all over x squared plus 1 all of that squared. Now let's take the second expression. The second expression says y is equal to cos to the full power of x. We want to find the first derivative with respect to x. Okay, this is the same as cosine of x all raised to the power 4. So here we have a function of a function. There is the inner function cos x and there is the outer function which is the power 4. The power 4 is a function. And so here, since we have a function of a function, composite function, we are going to apply what is known as the chain rule. The chain rule for differentiation. Now the chain rule says if we have a function y is equal to f of g of x, g of x is the inner function, f is the outer function. To get the first derivative, with respect to x, we are going to you have two possibilities. We're going to do the two possibilities. We'll first of all differentiate the inner function. Okay, we multiply it out. We differentiate the inner function, and then now we differentiate the outer function with respect to the inner function, f with respect to g of x. Okay, so I'll explain that. Okay, so here our inner function is cos x. So our g is cos x, and our f is the power 4. So our dy dx will be derivative of our inner function, which is sine negative sine x, okay, multiplied to the derivative of the outer function with respect to the inner function. That means we are going to look at this the same way as we look at x to the 4. This x here, or let us use a different letter, as we look at y to the let's use another letter, t to the 4, for example. How do we differentiate t to the 4 with respect to t? It will be 4t cubed. Okay, so cos x here, we'll look at it as if it is t. That's the meaning of differentiating the outer function with respect to the inner. And so it will just be 4 cos cube x. Okay, so when we arrange everything, it just gives us negative 4 cos cube x sine x. Okay, that's method 1. Method 2, we chain rule. This one is a mental method. The chain rule says we will let's say u be our inner function cos x. If that is it, then we'll get du dx, which is negative sine x. We'll get du dx. If u is cos x, okay, this is it, this is u. Therefore means y is equal to u to the power 4. So that means our y in terms of u will be u to the power 4. Now from here we'll try to get dy with respect to du. We'll differentiate y with respect to u. When we do that, we're going to have 4u cubed. Now, these are elements that we'll now put in our chain rule, which says dy dx is equal to dy du multiplied to du dx. Okay, so when we do this, we'll have our dy dx to be equal to dy du. This is our dy du. It's 4u cubed multiplied to our du dx. Our du dx multiplied to our du dx, which is negative sine x. This gives us 4u cubed into, well, minus signs come outside, negative 4u cubed sine x. Okay, we can't stop here because our question is in terms of x. We're asked to find dy dx and not in terms of u. So, but we know u. Okay, we know u is cos x. So this simply becomes negative 4 cos cube x sine x. So we see we obtain the same result. So this is the mental formula, the one that we use mentally if such a question comes in a paper 1 type of question, okay, where we need just 2 minutes to answer. All we need to do is to do this mentally. We differentiate the outer function with respect to the inner function. This is the outer function. We differentiate with respect to the inner function. We get that. And then we just multiply to the derivative of the inner function. And we just get our answer in less than a minute. Okay. Now let's take our last question. Our last question, C, is x squared plus y squared is equal to 16x. We have x squared plus y squared is equal to 16x. This is an implicit function. We know x is the independent variable, y is the dependent variable. So any expression involving the independent variable and the dependent variable is called an implicit expression. And so what we need to do in such a case is to differentiate each term with respect to y, with respect to x. So we're going to take we're going to d dx of each expression there. So we get d dx of x squared plus d dx of y squared is equal to d dx of 16x. We take d dx of each term. This is going to give us 2x. This one is 2x. Then here we have 2y dy dx. Then here we have 16. Okay. So from here we're going to make dy dx the subject. So to get dy dx, we carry this 2x from the left hand side to the right hand side. So we have 2y dy dx is equal to 16 minus 2x. The next thing, we divide both sides by 2y. We divide here by 2y, divide here by 2y. This cancels. And so we now have our dy dx to be 16 minus 2x all over 2y. Okay. Now we have 2 is common, so we simplify things out. We divide all through by 2. So we have 8 minus x all over y. So our dy dx will be 8 minus x all over y. This is the differential of that implicit expression.